I established a new scale, now called the Loeb scale. 0 on this scale signifies a purely natural object. For example, an observation in Chile recorded an object that should not exist in our area. This is a guest from interstellar space, who does not orbit our sun but simply passes by. This is only the third case in human history where we have confirmed something like this. This first happened with ʻOumuamua in 2017, then with Borisov in 2019, and now with Atlas in 2025. 3 objects over 8 years, all from different places. But Atlas has been different from the very beginning. Speed indicators raise questions. Data shows speeds from 26 to 30 kilometers per second upon approach. Quickly, yes, but not as fast as it should be. Most solitary objects move through space at terrifying speeds. Random fragments thrown by dead stars, chaotic, violent. Atlas moves slower, calmer, almost as if he is being guided by something. Orbital analysts begin conducting simulations. They track the path back not just over days or months, but over years, centuries, trying to determine where this object came from. Ultimately, a pattern emerges. Atlas does not spin in the void like a space debris. His trajectory indicates a structure, an order, as if he follows an invisible current in space. Some scientists begin to use a new term, dynamically cold interstellar flow. Translation: a hidden river of objects flowing through our galactic neighborhood. These are not random guests, but a convoy, a formation from icy worlds from the same place. If this is true, Atlas is not alone. He is simply the first one we noticed. For 72 hours, all major telescopes on Earth and in space are focused on the object. The Hubble telescope, Gemini North in Hawaii, the James Webb telescope. Everyone wants data. Everyone wants answers. Then the images come, and the observers notice something unexpected. Faint points of light near the comet, not at the core or tail, but separate sources. Several bright spots seem to move in step with Atlas as he races through space. Forums explode. Social media comes alive. Astronomy enthusiasts begin sharing enhanced images, zooming in, outlining anomalies, and posing a question that spreads rapidly. Are we witnessing destruction or something else? Speculations quickly turn wild. Some claim we see a fleet, others suggest natural fragmentation. Some even whisper about artificial origins. But here is where it gets interesting. When scientists begin to understand what these lights are, 3 possibilities arise. The first version is chunks of ice ejected by powerful jets. Atlas releases gas and dust as it approaches the sun. These jets are strong enough to eject fragments that temporarily move alongside the main body. Carbon dioxide ice, released and following the same trajectory for hours or even days before drifting away. The second version is stars. When Hubble tracks a fast-moving object, the stars in the background blur into streaks, short lines in the image. To the uninitiated, these streaks may seem like objects moving alongside the comet. NASA even noted this in its official release on Hubble's observations. The stars appear blurred because the telescope is tracking Atlas, not the background of the night sky. Let's consider a third possibility. These are true fragments. The core is disintegrating before our eyes, and it's truly thrilling because if Atlas is breaking apart right now, it is unusual. Most interstellar objects remain intact. They have survived millions of years in the cold void. Why does one of them begin to disintegrate as soon as it enters our solar system? As long as the thermal impact is not too great, and if this object is not made of something fragile that cannot withstand even distant sunlight. And this brings us to chemistry. When the James Webb Space Telescope aimed its instruments at Atlas in early August, the data was astonishing. Carbon dioxide was everywhere, and it was not just traces, not a minor component. 88% of the detected mass of vapor is the highest CO2 to water ratio ever recorded in comets. Ensure this: every comet we studied in our solar system was predominantly water, icy worlds with cores of water. Boris, the previous interstellar visitor, contained a lot of carbon monoxide and cyanides, but it still had acceptable levels of water. Atlas is different. This object is almost entirely made of carbon dioxide ice. This should not be possible under normal conditions of solar system formation, as CO2 only freezes at extreme distances, much farther than where ice from water forms. To create a comet with such a rich content of CO2, it must be born far from any star, in a frozen outer disk. where the temperature never rises above minus 100 degrees Celsius. Atlas appeared in the deep cold around a star, colder and dimmer than our sun. Perhaps it is a red dwarf, perhaps something even stranger. A planetary system where chemistry operates under completely different laws. This is not just an interstellar visitor. It is a sample from a world we can never reach, a frozen artifact from a solar system light years away from us. And if those bright spots in the images are real fragments, scientists are looking not just at one part of that distant world. They observe many samples, a scattered collection of exotic ice rolling through space together. Think about what this means. If Atlas disintegrates, each fragment carries the same chemical imprint, the same dominant carbon dioxide, the same alien chemistry. It's like finding pieces of a treasure chest from another civilization. Only the treasures are raw data on how other star systems create their worlds. In our solar system, there are temperature zones. Close to the sun, only metals and stones survive. A bit further, ice forms from water. Even further, methane and ammonia freeze. Each zone creates different types of objects. Atlas formed in a zone we have never explored, beyond even the coldest regions of our Kuiper belt. A place ruled by carbon dioxide where the physics of ice formation creates objects unlike anything orbiting our sun. If Atlas carries fragments, and these fragments consist of this exotic material, astronomers finally have the opportunity to study the planetary cradle of another star. No probes are needed, no interstellar missions. A sample has reached us, but the surprises do not end with chemistry. When orbital analysts measure the movement of Atlas, they discover something that raises even more questions. Before revealing this next twist, what do you think? Is Atlas traveling alone? Or are we witnessing the first confirmed parts of a hidden convoy moving between the stars? Leave your theory in the comments below. If you are interested in cosmic mysteries that challenge everything we thought we knew, don't forget to keep an eye on new discoveries by scientists. Now we come to where Atlas becomes truly strange. He does not follow the expected path. When astronomers track objects in space, gravity precisely indicates where something should be. The sun's pull, the influence of planets, pure Newtonian physics. The mathematics is clear and predictable. But Atlas does not completely conform to these calculations. Small deviations, insignificant jolts that shouldn't exist. The comet slightly deviates from the predicted trajectory. Not much, but enough to be measurable. Enough to be real. Scientists have encountered similar situations before. ʻOumuamua in 2017 did the same thing. This object accelerated as it left our solar system. Without an engine, without thrust, just an unexplained push that set the internet ablaze with speculation. The main theory is a gas outburst. When sunlight heats the surface of the comet, frozen material evaporates. Gas jets burst outward. These jets act like small rocket engines, pushing the object in the direction they are aimed. For many years, this explanation satisfied most scientists, but no one could prove its applicability to ʻOumuamua. The object was already too far away, too dim, too late to obtain detailed measurements. The Atlas changes everything, because this time we are witnessing it happen in real time. The James Webb Space Telescope tracks massive jets of carbon dioxide, measures their strength, and maps from which side of the core they erupt. Scientists can finally calculate exactly how much effort these jets exert. If the calculations match the trajectory changes, the mystery of ʻOumuamua will be solved. Natural physics. No exotic explanations will be needed. But there is an interesting nuance to this. If fragments near Atlas also emit carbon dioxide, they will drift as well. Each piece is pushed by its own currents, each following a slightly altered path. From Earth, this may appear as coordinated movement. A multitude of objects that together correct their course, not because they communicate or are controlled, but because they are all made of the same material, all reacting to sunlight in the same way. Flight and formation through physics, not design. And that is why scientists need more data, more observations, more time with Atlas while it is still close enough to study. This brings us to a painful truth. We might completely miss this opportunity. Atlas was discovered on July 1st. By pure chance, a random survey telescope was pointed at the right section of the sky at the right moment. If we had noticed this event 2 years ago, NASA could have done something revolutionary. They would launch a fast-acting probe, a mission designed to intercept interstellar visitors before they disappear into the void. Concepts for such missions have already been developed. Engineers have prepared plans, interceptors of comets, fast interstellar interceptors, spacecraft that can be launched in the shortest possible time and can meet targets moving at hyperbolic speeds. But they are not yet built, not financed, and not on launch pads ready for takeoff. Therefore, we observe Atlas through telescopes, millions of kilometers away, unable to touch it, obtain a sample, or place instruments on its surface. Agencies are in a hurry now as Atlas confirms that these visitors are real. They are infiltrating us, they can be detected, and they carry information that we cannot obtain any other way. The race to design the next generation of interstellar interceptors began. Machines that could be launched within weeks of detection, fast enough to catch objects moving at 30 kilometers per second, strong enough to survive close passes through alien dust clouds. But here's the thing. We might not have to wait too long for the next opportunity. The Vera Rubin Observatory is about to change everything. This institution will scan the entire visible sky every few nights, automatically, tirelessly, in search of everything that moves. According to current estimates, as soon as the observatory begins full operation, we will be able to detect dozens of interstellar objects each year, perhaps even more. The influx of information will turn into a stream. ʻOumuamua was a surprise. Borisov confirmed it. The Atlas is the third indicator, but soon we will be buried under a pile of interstellar guests. Each of them is an envoy from another star system. Each carries evidence of worlds we will never be able to visit. The Atlas may turn out to be the last object we study in the old way, hastily aiming every available telescope at one target, extracting every particle of data before a failure occurs. I don't think this is Florida. Fortunately, I didn't need NASA. I needed a legal team. It turned out there is a law firm named Morgan & Morgan, the largest in America in the field of personal injury law, with over 1,000 lawyers and more than 100 offices across the country. I tried to contact one of these local lawyers with advertising jingles. I waited on the line longer than the delay of a Mars launch. Meanwhile, Morgan & Morgan helped a client in Florida get $12 million after the insurance company offered only $350,000. Morgan & Morgan only get paid if they win the case. No upfront payment. You can file a claim without getting off the couch or even while in the jungle. It's that simple. Just click the link in the description or scan the QR code on the screen. If you ever get injured, you can contact Morgan & Morgan. Their services are free if they do not win the case. You can start your claim by clicking the link below or scanning the QR code on the screen. Future visitors will become a regular, expected part of the systematic examination. We will determine the priorities, which objects are worth studying, which require missions, and which can be left alone. That is why the Atlas is so valuable. It is the last glimpse of an era when interstellar objects were rare mysteries, not just catalog items. And the Atlas has one more surprise for us. An experiment we could not have designed even if we tried. In the year 2026, this comet will fly close to Jupiter. Close enough for the gravity of the giant planet to capture it, change its trajectory, and accelerate it as if it were a natural slingshot. Orbital mechanics on a cosmic level. Jupiter acts as a lens, a laboratory, a way to refine our models of interstellar debris, interaction with massive worlds. If fragments exist, Jupiter's gravity will affect each of them differently, depending on their mass and exact location. The meeting will either gather them together or scatter them through space. Scientists lack patience, as this is a unique event of a generation, a pure test of gravitational physics using objects from beyond our solar system, data that will improve our predictions of future visitors' trajectories, aiding in interception planning and collision risk assessment. This is not just academic curiosity, it is vital for survival. Interstellar comets carry not only interesting chemistry but also risk. These objects move quickly, strike hard, and we cannot predict them until they are already nearby. Atlas will pass safely, posing no threat to Earth. But the next comet, and the one after it, require us to understand their orbits, their behavior near giant planets, how their trajectories bend and shift while navigating through our solar system. Jupiter becomes our laboratory for protection, a free experiment that teaches us to track and respond to interstellar threats. But there is a deeper reason to care about Atlas. Beyond science and missions, This object may carry the building blocks of life. Interstellar comets deliver raw materials between star systems, organic molecules, water, carbon compounds, chemical elements necessary for the emergence of life. Each young planetary system is bombarded by debris, some local and some interstellar. Objects like Atlas rush by, colliding with newly formed worlds and seeding them with chemistry from across the galaxy. Earth could owe its existence to such visitors, comets that brought water to a dry planet. Organic compounds that initiated the first chemical reactions leading to life. If Atlas-type objects are widespread, then the ingredients of life have a chance of being everywhere. Each star system receives contributions from its neighbors, a space exchange program that has existed for billions of years. But the process works both ways. If interstellar comets bring useful chemistry, they can also bring dangers. Exotic ices that react with atmospheres, compounds toxic to local biochemistry, contamination from alien chemical regimes. The study of the Atlas teaches us what to expect regarding the substances that pass through interstellar space and what young worlds must cope with as they develop. These are not abstract studies. Understanding our origins, our vulnerabilities, and our place in the galaxy, which is much more interconnected than we realized. Let's discuss what is on the surface. You have probably seen the headlines screaming about the fleet accompanying Atlas, about numerous spacecraft moving in formation, about extraterrestrial convoys. Now let's figure out what is really happening. Astronomers observe a single comet, its nucleus surrounded by dust streams and possible small fragments. The bright spots in the images can likely be explained as a mixture of carbon, two chunks, background stars smeared when observed through a telescope, and image artifacts. All of this can be explained. These are all natural phenomena. Could there be debris? Yes. Comets break apart. We have seen this before. Borisov shattered into pieces, and Shoemaker-Levy 9 broke into a chain of fragments that crashed into Jupiter. But the debris does not fly in formation. They drift apart, separating. Physics gradually pulls them apart. The true mystery lies not in the convoy, but in the fact that we are finally beginning to see pieces of other suns passing by. The Atlas represents the first detailed look at material from a completely different stellar cradle. Only chemistry revises our assumptions. The trajectory hints at hidden currents flowing in our area. A future meeting with Jupiter will teach us how interstellar guests behave near giant worlds. This is a groundbreaking discovery, and no exotic theories are needed for explanation. The scientific data is already impressive. Let's step back a bit and consider Atlas in context, as this is not the first time an interstellar guest has made us rethink our understanding of the cosmos. In October 2017, the observatory in Hawaii notices something moving incorrectly, too quickly, at the wrong angle, with a trajectory that does not close into an ellipse around the sun. A hyperbolic trajectory, open from both sides, the object is named ʻOumuamua, which in Hawaiian means scout, the first confirmed guest from another star system. Scientists rush to gather data. Every available telescope is aimed at it. But ʻOumuamua is already leaving, rushing back into the void, spinning and accelerating for reasons that no one can fully explain. Debates flare up. A natural comet. A nitrogen iceberg. Something else. Years later, we still have no consensus, only theories and assumptions based on incomplete data. Then, in August 2019, another discovery. This time tracked much earlier. A comet designated as 2 and divided by Boris. Hyperbolic trajectory confirmed. Origin: outside our solar system. But Boris behaves like a comet. It emits gas, forms a tail, showing carbon monoxide and cyanide in its spectrum. Familiar chemistry, understandable physics. Scientists breathe a sigh of relief. Borisov proves that interstellar visitors can be ordinary, natural objects, following the laws of nature. ʻOumuamua becomes an exception, a strange one that perhaps does not need exotic explanations. And so, in July 2025, Atlas arrives, the third confirmed interstellar object in human history. 3 visitors in 8 years. But Atlas does not fit into any of the previous schemes. It is not as mysterious as ʻOumuamua, nor as familiar as Borisov. A completely new phenomenon. The supremacy of carbon dioxide, record ratios, chemistry from a stellar medium that we have never explored. ʻOumuamua demonstrated that interstellar objects truly exist. Boros showed that they can be ordinary. Atlas, however, demonstrated that they can be alien and unpredictable. 3 data points, 3 completely different profiles indicating the diversity of interstellar debris, its vast variety of objects from thousands of different star systems, each with a unique formation history. But here's what changed behind the scenes. How we find these visitors has evolved. ʻOumuamua was luck, pure chance. A telescope scanned the right section of the sky at the right moment. Human astronomers noticed something strange in the data, marked it, and began manual investigation. Boros was similar. He was discovered by an astronomy enthusiast named Gennady Boris using a homemade telescope. The right place, the right time. Human intuition recognized the anomaly. But Atlas, that's a different story. The Atlas survey in Chile operates automatically. 4 telescopes scan the sky every night, searching for asteroids, threats to Earth, anything that moves. But detection is no longer exclusively human. Machine learning algorithms now process the data first. Neural networks trained to recognize hyperbolic trajectories. Artificial intelligence identifies potential interstellar candidates even before humans look at them. Atlas was captured by an automated process, software that never sleeps, never blinks, never misses a shift. This is a new era. We are moving from random discoveries to systematic detection, from luck to predictability. The Vera Rubin Observatory will be fully operational for 5 years. This institution will turn everything upside down, scanning the visible sky every few nights, finding transients, tracking moving objects, cataloging everything that changes. Current forecasts suggest that Rubin will discover interstellar objects at a rate of dozens per year, possibly hundreds, as we refine our detection algorithms. A small stream turns into a flow, and with this flow comes a complete transformation in planetary science. Because before ʻOumuamua, most scientists believed that interstellar visitors were a rarity, theoretical possibilities, events that might happen once a century, background noise in cosmic dimensions. Now, we know the truth. The galaxy is full of these objects. Wandering planets, cast-out comets, shattered asteroid debris drift between the stars, constantly crossing every planetary system. Our solar system is not isolated. It floats in a sea of interstellar material. Some of these objects pass unnoticed. Some are captured by the sun's gravity and join our Kuiper belt. Some collide with planets and moons, bringing chemistry from distant galaxies. Earth has received interstellar supplies for 4 billion years. Water from alien comets, organic molecules from distant nebulae, building blocks that could ignite life. We no longer study rare anomalies. We study the fundamental process. Galactic mixing. A constant exchange of materials between star systems. A cosmic conveyor operating since the formation of the first stars. Atlas is not an anomaly. It is a specimen, a messenger, showing us what traverses the interstellar medium, facing what every young planetary system encounters in its development. So, let's figure out what we actually learned from Atlas. First of all, this object is not just another comet. The prevalence of carbon dioxide indicates something revolutionary. The Atlas could become our first proof that entire populations of carbon-rich bodies drift through the galaxy, icy worlds formed in the deep cold around dim stars. Chemistry so extreme that it rewrites our models of what planetary systems can produce. Secondly, the mysterious bright spots that sparked all the speculation are likely a combination of carbon monoxide, particles ejected by powerful jets, background stars blurred when viewed through a telescope, and image artifacts, natural explanations, nothing that required exotic theories. But here is what is important. The real story is not about whether fragments exist. The main thing is what Atlas represents. Alien building blocks drifting past us. Chemistry from another solar material that we will never be able to reach. Brought to our doorstep by streams of galactic space, the Atlas carries information encoded in its ice. Temperature records from a distant protoplanetary disk. Evidence of which molecules survive in the void between the stars. Evidence of conditions of formation that we cannot reproduce in any laboratory. Every measurement we conduct teaches us about worlds light years away from us. Each spectrum reveals secrets about stellar neighborhoods we will never visit. And if Atlas belongs to the cold interstellar flow, as its speed suggests, then it is not alone. Somewhere out there, countless frozen worlds are being freed from their birth systems. They drift between the stars, penetrating planetary systems, sowing young worlds with the raw materials necessary for life. This is the Great Migration of the Galaxy, an exchange program that has been in operation for 4 billion years, connecting every star system through wandering ice and stones. We are not isolated. We are part of a network, a cosmic web, where matter flows continuously, where chemistry mixes over light years, where each planet receives contributions from its galactic neighbors. Atlas is our message in a bottle, proof that we are part of something immense and ancient, shaping the evolution of worlds since the first generation of stars perished and scattered their remnants. Think about what this means. Right now, objects from our solar system are drifting outward. Comets ejected by Jupiter, asteroids cast into interstellar space by gravitational interactions. They will travel for millions of years, crossing other star systems, possibly delivering Earth's chemistry to alien worlds we will never know. In return, we receive visitors like Atlas, messengers from distant suns. Each of them is a time capsule. Each carries information about places human probes will never reach. The next interstellar guest may appear any night. It can be rich in carbon monoxide, like Borisov, or dominated by nitrogen, like possibly ʻOumuamua, or represent something completely unexpected, a chemistry we haven't even imagined, ice formations that challenge all our knowledge. We live in an era when humanity finally sees the galaxy as it truly is. It is not empty space between isolated stars, but a connected system, a flowing network of matter and energy, a cosmos that constantly mixes, shares, and redistributes its building blocks. Atlas will not be the last. This is just the beginning. The first detailed picture of what flows through the cosmic rivers crossing our neighborhood. If you want to keep track of the next interstellar discoveries in real time, follow the news, as detection algorithms are already working, scanning the sky every night. The next guest may appear in the data as soon as tomorrow. Another fragment from another world. Another message from the Great Galactic Migration. You won't want to miss this.